Welcome. Welcome to the talk and to the session, and welcome to DevOps. Great to see you here. My name is Martin Lippert. I work for VMware, and I'm part of the core Spring engineering team. That's why I proudly wear this Spring shirt. So usually I work in the Spring core engineering, so the people doing the Spring Boot, Spring Framework teams, Spring Framework stuff. And I'm specifically working on the developer tooling inside of Spring. So Spring IDE, Spring Tool Suite, Eclipse and VS Code, specific tooling for Spring. That's the stuff that my team is doing. So that's what I do day to day. And that's the reason why I go to work in the morning, to basically make you as a Spring app developer more productive during the day. Right? That's why I do that. And I really like to help folks out in the world on hacking and doing software engineering, because that is what I love. I love doing software engineering all the time. I started programming when I was 12 or something like that. And since then, I really enjoyed it. I enjoyed it so much that I spent all my working life dealing with software one way or the other, implementing software, working on software, and finally implementing developer tooling, so tools for other software engineers to make their lives easier. But that is not the reason why I'm here. It's not the reason why I'm giving this talk about sustainability-related things. It is because way back, many years ago, there was a company that I founded with colleagues. It was called IT Agile. It's kind of an agile consulting company, because I was very much into agile software development back in the time. And when we did that, we thought a lot about the impact that the company has on customers, on other people in the world. We spent a lot of time in the community, and we thought a lot about our environment, basically the world that we live in. It was kind of part of our DNA inside of this company, being very focused on kind of social aspects, very focused on helping people, being better at work, producing better software, all those things. And when we started to do that, we figured out that as a consulting company, we were traveling a lot, right? We were kind of flying all across Germany, basically, at that time, mostly Germany, all the time, flying to customers. I myself, I was flying kind of every week, right? It was kind of these typical consulting things, like Monday in the morning, you fly out somewhere, and then you return back on Thursday or something like that. And we figured out that this is that's not great. It's not great to be on the plane all the time and causing so much emissions. And we thought about what can we do about that. And one of the aspects that we found back then was, we should maybe look at this. There was a small company called Atmosphere. They're doing this carbon emission offsetting stuff. That sounds interesting. That sounds like we can give something back. We can try to work on these emissions. We can try to do something to fight that. And so we calculate all our flights, and we calculate the carbon emissions, and we paid money to Atmosphere to kind of offset those things. It was in the early days, and it was, when I really think about that, it sounds like that was last year or 2 years ago, right? It sounds like carbon offsetting. But actually, we did that 12 years ago. Nobody was talking about Fridays for Future initiatives. Nobody was talking about big climate changes and things like that, at least not in the broad community or in the basically all over the country. So we were thinking about that, and we started. And since then, it was a topic that kind of kept lurking in the back of my head. And I was thinking about what can I do in my private life, so switching to renewable energy providers, these small things that immediately come to your mind when you think about that topic, and you're trying to do kind of the right thing, right? And I tried that, and I think I failed several times, and thinking back about these carbon offsetting that we did back then, and continuing to fly was probably not the best idea that we had, looking back, but it was one part of this journey. And then I switched companies, switched jobs. I worked on software engineering, software developer tools. So really focusing back on not traveling all the time, not helping customers on the consultancy base, but really helping developers with tools and with the IDEs that they use. The thought came back about what can I do? Or what if I can combine those two things that really drive me, that I really care deeply about? What happens if I would combine those stories about helping software engineers and doing software engineering all the time and thinking about sustainability at the same time? How do those topics relate to each other? Do they have any overlap? Is there anything that is related to sustainability inside of software engineering, or is it kind of totally separate? So I started to investigate this area basically a few years ago. And this is basically my journey through this combination of topics. And I would like to take you with me on this journey that I started a few years ago to think about what is kind of the sustainability aspect of my work life, basically, as a software engineer. Not only looking at tools, but only as software engineering in general. And this is basically what I would like to talk about, and what I would like to take you on with me on this journey. So when we think about sustainability, and some people told me that actually not too long ago, when we take the word sustainability, it actually means different things, and it has a broader scope than the stuff that I immediately thought about, which was, sustainability, that's all about climate change, that's all about saving the environment, that's saving the planet. It's actually more. Sustainability, and if you come back from the agile software development, you might think about sustainable software engineering back in the days with the meaning of allowing a team to sustainably produce software at a good speed, at a good pace, and not collecting technical debt. So you see there are kind of different associations with this word. And in general, sustainability covers three different pillars. It's kind of the social aspect of sustainability, it's the economical aspect, and it's the environmental aspect. So the environmental aspect that we thought about at the beginning, climate change, the planet, the environment. And sometimes it is quite useful to keep those three pillars in the back of your head, in the back of your mind, because sometimes it's easy to think about improving one part at the cost of another part, right? So the easiest equation here for me would be, you're doing software engineering, you're causing carbon emissions while you're doing that, so stop doing that, forget about it. Shut down your business, shut down everything. That would kind of eliminate your carbon emissions. Oh, that's awesome. That's an easy solution. But of course, it would kind of sacrifice the economical aspect of that. So we cannot just look at one part of the equation. We need to keep the other things in mind, right? And that's what we need to do. Nevertheless, I would like to focus on the environmental aspect in this talk and in this session. And because this is the major driver on my journey through this topic. So we all know that climate change is real, so we don't need to talk about that. I'm not here to educate you and to tell you about climate change and why that is real and what is causing all that and things like that. We all know that, right? That's fact, right? And we know that the greenhouse gas emissions are kind of the main problem in this equation. So we need to get rid of basically the greenhouse gas emissions, containing a lot of kind of carbon emissions, but other greenhouse gases as well. We heard about that in the keynote this morning. And of course, when we think about this topic in general, we need to think about where do those emissions come from, and they come from energy. It's basically energy production. That's kind of the main driver. It's not the only source of greenhouse gas emissions. There are other aspects of this, but energy is a major driver. So when we start to think about software, we need to think about energy at the same time. So, but what does it mean? What does it mean if we think about sustainability and software engineering in total and not purely focus on the energy aspect? You might immediately think about, okay, software, energy, I run my software somewhere that uses energy, and that's the stuff that we need to look at. When I think about that, and really think about we need to decarbonize and get rid of these greenhouse gas emissions, software engineering covers a lot more. There's a lot of stuff involved, and a lot of stuff in your life as a software engineer that causes carbon emissions. It's not only the energy production, it is the production of the hardware. We heard about that in the in the keynote this morning, the different aspects of these emissions, kind of the scope 1, scope 2, scope 3 emissions. So if we look at those things, there are kind of many carbon emissions being produced along or based on those different aspects. So we can think about commuting to work. Actually, when I talked to a company, it was also a consulting company, and they were kind of doing software engineering as well and doing kind of client engagements, but only on a remote base. So what's the major driver? It was kind of people coming to the office, actually. That was kind of a big driver of emissions in their day-to-day work. It was maybe not powering the laptop with energy, it was actually commuting to work. So we need to look at this a little bit more holistically and think about what are kind of the big drivers that we have in this equation when we think about our work life and what can we do about that. And there are all the aspects on this slide and probably a lot more aspects. And even if you think about things like, oh yeah, we work remotely, so I sit at home, so that's great. And I do Zoom meetings all the time instead of traveling around, instead of commuting to the office. But what's the cost of those Zoom meetings, actually? And there's research going out there comparing the energy involved and the carbon emissions involved in kind of video calls compared to actually meeting on site and traveling and so on. And of course, video calls are a lot better, right? Produce a lot less carbon emissions, but it's not zero, right? You still cause a lot of stuff, and if you involve more people in that, it already started to change the equation. So we need to look at those things as well, and we cannot ignore that. And part of our life as software engineers, at least one part that I enjoy very much, is going to a conference, right? Going to a conference, meet other people, speak with the community, get feedback, from time to time give a talk. And when we think about this conference is causing carbon emissions, right? That's a fact. And I traveled here from my hometown, which is Hamburg in Germany. So this is basically my rough equation of what I cause as carbon emissions traveling. So I took a flight it was just one flight, the direct flight from Hamburg to London. And you think about the flight, of course, kind of that's a big part of the equation. That's good. But what's kind of the next big part? What's the next big part beyond the flight? What would you think? You might think about, I don't know, maybe the public transport to the airport. Maybe it was a car, or the taxi, or the public transport to the airport. Actually, it's kind of me staying here at the hotel. Staying at the hotel is also a big chunk causing carbon emissions. And if you travel around, take into account that staying at a hotel also causes a lot of carbon emissions. The company that I mentioned at the beginning, that I founded many years ago, the IT Agile company, they are still very much in this consulting business, and they do a lot of on-site training sessions. And they thought about what are the biggest drivers for our carbon emissions? It's kind of heating the office. It is our energy consumption. It is what is it? And actually, of course, it was kind of the travel involved by participants, attendees coming on site for the trainings. They're taking trains and they're flying, right? That's a big chunk. What's the next big chunk? The next big chunk was them staying at a hotel during the training. That was the next biggest chunk. And then, if you look at then kind of the energy consumption on site, it was a lot less. Very small chunks. So you need to really think about those things and start to, what Azim also mentioned in the keynote this morning, you start to kind of think about that, measure that, get a feeling about where are my carbon emissions really. Back to software. So let's talk about the energy and let's talk about our software. And of course, we start to think about, and that was kind of my immediate thought at the beginning, of course, there's the data center where we run our software in. So, of course, we need to look at that. And kind of, it looks like, oh, that's good news. That's a great topic to look at, because if you look at these data centers in the public clouds, they all have something on their slide saying, oh, wow, we are 100% carbon neutral. Or, oh, yeah, we are 100% running on 100% renewable energies. Or, oh, we have renewable energy production even on site, like solar panels and things like that. Oh, that's awesome. Sounds like perfect, right? No need to worry about that. The bad news is your workloads that you run on a public cloud, they do not run on renewable energy all the time. We heard about this carbon neutral thing in the keynote this morning, that carbon neutral only means that you do not really reduce your carbon emissions, you just kind of offset them, and that's what many companies do, right? They offset emissions. They still produce a lot of carbon emissions, and they kind of put that into the atmosphere, but they offset that with projects like planting trees or giving other people money, things like that. Even a company like Avis, it's basically a company based on renting cars all the time. That's their business, renting cars. And those cars running combustion engines, so producing greenhouse gas emissions all the time. Even a company like that is 100% carbon neutral. You might ask yourself, how could that be? Isn't that strange? Of course, they offset all the stuff. They invest money into these offsetting projects or planting trees, which is not really getting stuff out of the atmosphere again, but that's a different topic, why offsetting stuff is really kind of a bad idea. So when we look at the data centers, your workloads do not run on renewable energy all the time. And if you look into the details, it is first, there is down the line, there is not enough renewable energy to power all this stuff. And of course, you can think about, okay, I buy renewable energy at the exact same amount that I consume. Like a data center company is doing that, right? I go to a renewable energy provider, I buy the renewable energies in the same amount that I consume, so I'm running 100% renewable energy, but it is not really increasing the total amount of renewable energy that is available. So you are more or less shifting that towards the data center, but somewhere else, someone who is consuming energy is having less renewable energy available. Of course, over time, we need to increase that, we need to produce more renewable energies and so on, but at the moment where in total, we don't have 100% everything running on 100% renewable energy all the time in our economy, it's not enough, right? The next thing is that the production of renewable energy varies a lot, right? The stupid example, the wind doesn't blow all the time, the sun doesn't shine all the time, right? So if you look at how much renewable energy is being produced at what time, it varies a lot. And that is not exactly the same as the data center consuming energy. So there's a difference, right? Sometimes there is not enough renewable energy to power the data center, so the data center consumes energy from the grid. Let's say dirty energy from burning coal and burning oil or whatever, burning gas. Another time, maybe there's more renewable energy available than the data center uses, so there's more available for someone else. So it's kind of, maybe the equation over time sums up to zero, which is great. But it does not mean that your stuff in the data center runs on renewable energy all the time. There are very, very few exceptions to that in the world. In the whole world, there are very few data centers running on renewable energy 100% all the time. Very few. Even companies like Google, who are really kind of at the forefront of putting everything on renewable energy for all the data centers, even for them, it's a really hard and tough job to get there, and they are not there yet. So, and at the same time, bad news is we put more and more stuff into the cloud, into those data centers, right? More workloads, more stuff, using more energy. And of course, hardware and the data centers, they get more efficient. So today you can run a lot more stuff than 10 years ago at the same amount of energy, but in total it is still increasing. And if you look at this, there's some studies, you can even talk about that, whether it's kind of a serious one or not so serious one, but it's a pretty common consensus that the total energy consumption of data centers in the world will most likely achieve in maybe in 10 years or by 2030, a level of 10% of the whole energy production in the world. 10% of that is consumed by data centers. And why do data centers exist? To run your software and to store data. So if we think about this, the data center consuming the energy and you producing software that runs in the data center, there's quite an angle that we have. There's quite a responsibility that we have to think about that. So remember, there's still a long way to go. There's still a long way to achieve this goal of maybe we can sit back and say the data center runs on 100% renewable energy all the time, so at least I don't need to think about that part. I still need to think about all the other parts, right? But at least I don't need to think about that. But the consumption is increasing, the renewable energy production is increasing, but will it meet someday in the future? Or will the consumption grow faster than the production? I think it is better to approach it from both sides, actually, to increase renewable energy and to decrease the energy consumption at the data centers. So we cannot just wait. We cannot just wait and relax and think someone else will solve the problem. Someone else will take care of, oh yeah, the data centers, they will all produce stuff on green energy all the time in the future someday, right? Maybe we will not get there if we continue doing stuff the way we do it at the moment. So I think this transition is not fast enough. And we, as software engineers, we can have a huge impact in speeding this up. We can have a huge impact in speeding up this transition so that we get to the point a lot faster than we thought about. So what should we do? What should we do instead? Just waiting. The first thing, my first advice, the first thing that I found is do not run your software. And that sounds a bit like the crazy idea at the beginning, like, oh yeah, shut down your business, forget about everything, then you don't do anything bad. That's not the point. The point is, if you do not run your software, you're not really causing or consuming energy. And if we look at real data, right? Why should we write software? We write software to run that. Of course, we do that. But if we look at the real world, what happens in reality? We see that so-called zombie workloads are a real problem, which was really interesting, really surprising to me, because zombie workloads, that's a terminology from a research study. People looked at, not people, it was kind of Jonathan Coomey and John Taylor. They looked at data centers in the world, and they analyzed data centers. And they looked at those data centers and said, okay, we measure the workloads that are deployed in those data centers. We measure them over 6 months, roughly, at kind of different intervals and whatever. So I don't go into all the details of the study. If you want to know the details, feel free to take a look. But in the end, they kind of found out that we can group the workloads into 3 different categories. One is zombie workloads. Those are workloads that do not show any activity over a period of 6 months. Nothing. No CPU, no network transfer, no user interaction, nothing. Zombies. Total zombies. Nothing. They had a few other categories. And they looked at those data centers, real-world data centers. What would you guess? How many zombies? How much stuff on the data center is zombie? You will be surprised. It's about, let's say, the rough number is about 1/3. 1/3 of all the stuff that they found in the data centers was pure zombie stuff. You could shut it off. Nobody will notice anything, right? Get rid of it. It's a huge waste of energy. Because these zombie workloads, when you deploy them, when you deploy the software in the data center, there are resources being reserved and blocked for your workload, right? The memory and the CPU and whatever you define for your workload is reserved. And of course, a CPU is not consuming as much energy if it does nothing compared to it runs at kind of full load, It kind of reduces the energy consumption a lot and so on. But keeping the memory around, powering everything up. Basically, when I talk to people running data centers, they basically said, okay, kind of as a rough estimate, you can think about if you deploy your stuff and it doesn't do anything, it still consumes 50% of the energy of the data center. Right, roundabout. So it's not kind of scaling down to 1% or 0 or whatever. It's still consuming a significant amount of energy. So really think about those zombies and get rid about those zombies. And to be honest, I created those myself a lot. Whenever it's so easy to go to a public cloud and say, oh yeah, of course, I need for testing, let me create this quick Kubernetes cluster with these nodes and a few things. Oh, I need a lot of memory, and oh, I need to test my workloads. And I do stuff and show the stuff at the conference, at a talk. And 5 days later, I remember, oh my God, the cluster is still running. Oh, I forgot to shut it down. Right? That happened probably 100 times for me. So 5 days, nothing happens, right? It's just wasting energy. And if you look at the real world data, it's a real problem in data centers. VMware, so the company I work for, they did a big data center consolidation. I think it was in 2017, I think, where they had a data center in Singapore that they wanted to move. So they did something like, okay, we need to take a look at what's running inside and not just blindly move everything. Let's really take a look at get rid of stuff that we don't need anymore. And for that data center, it was 2/3. 2/3 was not used at all anymore. So they could just delete everything. Maybe it's special for a virtualization company to have a lot of more zombies than other companies, but it's still a big problem for other companies. So get rid of that, right? Really kind of do some stock taking. Think about that. What can you shut down? The next thing is, do not run your software when it's not used. And that also goes back to the research study that the next group that they looked at were workloads running for less than 5% of all the time. Right, over period of 6 months, when they measured stuff, less than 5% was showing some activity at least, right? But nothing in the remaining measurement points. And these, what they called idle machines, round about another third. So you can think about the data centers running your software, 1/3 zombie stuff, not used at all anymore. Another third is probably being used for less than 5% of the time, really used, really active. And 1/3 doing that. It's not the exact numbers, right? It varies a little bit about what cohort exactly and if people were aware of the problem, how that changes over time. But to just give you a rough impression, we're not talking about 1-2%, one single percentage things. We talk about single-digit percentages. We talk about big chunks about these idle machines. And that's, I think, true for a lot of software, maybe not up to the degree of 5%. Maybe it is, the usual stuff that are run at the consulting, no, not the consulting, at the, let's say, the insurance company. I write software for insurance company. It powers all the people work there in the office. The stuff is used basically for 8 hours a day. Still running for the remaining hours? Probably. Who knows? Still consuming energy? Maybe. At least worth to take a look into and think about that and really start to think about hacking software that is able to scale down to 0 and aggressively using this approach. Use a platform that can scale down your stuff when it's not used and use architectures for future software development that allow you to run software with a scale to 0 approach. So aggressively scale that down. When it's not used, do not run it. If you run that just because you don't know when the next request comes in, when someone will use it, I'm not sure about that, and maybe you're waiting for an hour, you may be waiting for a day, who knows, right? That's bad. A requirement for that is, of course, fast startup. So if you think about these kind of scale to 0 architectures, there are a lot of kind of technical requirements. You cannot just say, oh, I have my big old, let's say, Java Enterprise application that runs on this application server. Oh, I start it up, and then it warms up the caches for 5 minutes, and then it JIT compiles everything, and until we can really use it, oh, it takes maybe 10 minutes or something like that. Oh, I scale that down to 0 and start it up when someone uses it. You cannot really do that, right, at the moment. But you should start to think in this direction, because it is important. The next question is where to run the software. So when you run your software, where do you run the software? What is the kind of, maybe you're using a public cloud instance, maybe you use a private data center, I don't know, but think about that. The location of the data center could have a big impact. So choose the data center wisely. For example, if you go to something like a kind of a Google Cloud platform, they start to show you kind of the carbon impact of the different regions. So it could make a big difference if you deploy your workload in another region, if that's possible, from your software perspective, like from network latency and whatever. But if it's possible to switch it to, let's say, to a greener region, that makes sense because the data centers vary a lot. The data centers running at certain periods of time on much greener energy, maybe and a lot more renewable energy than other data centers. We need this transparency for that. So we need those data centers to give you this information, to provide you with this information. This is what's kind of very heterogeneously at the moment. It's not really, you cannot really get it. There's no website saying, oh, give me the data center with the greenest energy at the moment, and it just lists you all the data centers of all the companies and whatever. That's not possible at the moment, but we need to get there. And I think we will get there in the future. There will be a point where every data center is being fully transparent about what is the energy mix that I'm running on at this moment. What's the energy mix for the next hour? What's the energy mix for this day or this period of the day? And you will have the ability to choose the right data center and to think about that. And if you run your stuff on the data center that does not provide you the information, please go out and ask them for this information. Ask them, say, you want to know this. You're running your stuff in this data center, whether it's on-prem, whether it's your private stuff, whether it's a kind of a public cloud, whatever. Go there and ask for what is your carbon impact at the moment. Give me this data. I want to see this, and I want to compare this to maybe another data center, or I want to compare this to how do we improve over time. Super important. If you go one step further, you can also think about, once you have this data, to automate that. For example, there's a research paper on Kubernetes scheduling algorithms, so where Kubernetes decides on which node to run your workload on, depending on various conditions. And they thought about, okay, we should kind of think about putting the energy mix and the carbon emissions that the data center consumes at this moment, and there is kind of, at least there is a public API out there where you can get data from the grid, from the energy grid, and the renewable energy percentage of the grid at the moment. So you can roughly get an idea about what the data center might run on. So where they take that into account and put that into the scheduling algorithm, so that the scheduling algorithm for you can decide on, I move the workload around for you fully automatically, and I shift it over to a region with a better energy mix all the time. In case that is possible, or in certain boundaries. Probably for your network latency, you will be surprised if your workload moves around the world to the other end, because the sun shines over there a lot more at the moment, I don't know. So it's also not an easy solution, but it's an interesting, innovative way to think about that, because in the end, automating that makes a lot of sense. When we go beyond where to run the software to when to run the software, is also an interesting question. So do you really need to run your software all the time? We already talked about the scale to zero architectures, but maybe you also have software that runs periodically, kind of batch jobs, things like that. Can you think about kind of telling the data center or the platform maybe to say, oh yeah, you can schedule this workload I need to run that within that time frame, but I don't care about the exact timing of that. As long as it's within this time frame, decide yourself. And the platform, the data center, the energy provider, not the energy provider, the data center, depending on the data from the energy provider, decides when exactly the best timing is to run your software, depending on the energy mix. So let your data center decide that. It's also nothing that, or it's at least up to a certain degree, it's possible today. I think there at AWS there are certain instance types that you can choose, I think, but I'm not an expert on that. But I'm pretty sure more of this will come because it makes it a lot easier for the data center to move your workloads around and to achieve this goal of running on renewable energy all the time, at every moment, a lot easier, because they can move workloads around to a point in time where more renewable energy is available. And of course, the next, maybe not the last resort, but it's also important, write better software. And not write better software in terms of more features and more performant and things like that. Of course, you should continue to do that as well. But think about your energy consumption and the hardware consumption of your software. And this slightly changes the mindset a little bit. I think for many people that I talked with, I had this mindset when running stuff myself, this mindset of, oh, I run this thing in production, this enterprise thing, or the backend service, oh, that needs to be available, that needs to be reliable. Yeah, maybe we should give it a little bit more memory just to be sure that everything goes fine. Oh yeah, let's do a slightly bigger machine just to be sure that it's really behaving nicely. I don't really know whether it's really using that or needing that, but to be sure, let's try to give it a little bit more, more stuff. And more stuff is easy. I can just click on at least when I run on the public cloud, I just click on the other node instance and say, yeah, more CPU, that's easy. Oh, price, that's reasonable, go for it. Like, more is better. In this case, more is not necessarily better. Think about CPU, memory, and network. Those are kind of the three big drivers. And that CPU consumption, that's obvious, right? Powering the CPU costs a lot of energy, but also reserving a lot of memory costs energy. You can roughly think about, if you have 1 gigabyte of memory for your instance, it roundabout consumes 2 watts of energy. Right? You can scale that up. Right? It sounds small. And this is sometimes when you think about these network and memory and CPU stuff, we think about these kind of very small things, right? 2 watts? What's 2 watts? Nothing. But then you think about who deploys stuff with 1 gigabyte of memory? Anyone? Running with less than 1 gigabyte? Ha! Good stuff. So 2 gigabytes? Maybe 4. Let's use 8. No, the node is that's so tasty. It has 16 gigabytes of memory. Oh, now you have 32 watts. Oh, that's just for the one node, but we scale our stuff up to 100 instances if necessary. Oh, that's multiplied by 100. Oh, we run that for basically all the time. Oh, that's multiplied by hour, by days, by weeks, by month. And suddenly you arrive at numbers that are remarkable. And kind of let's say the bad news in this is that if you put these numbers on your workload, these reserved resources, for example, when you deploy stuff to Docker or Kubernetes or whatever in a containerized thing, you usually put these numbers and say, okay, the limit is, and the resource consumption is, whatever. That consumes energy. The moment you deploy that moment it consumes energy on the node. Whether you use it, whether it runs at full speed or not, matters, but it does not reduce stuff to zero. So really think about that. When you put these numbers on your workloads, think about those numbers and think about, can I maybe run the same stuff with less? Can I run my workload with less memory, with less CPU? And the stuff that I have in mind for that is always, can I run my workload with less hardware? Can I really try to run stuff with less hardware? A lot of stuff kind of drops out of this equation, like, oh, okay, of course I need less CPU, less memory, probably less network, and so on. So can I do that? To put that into perspective, these numbers are small numbers, right? Very, very small numbers. So when you think about you deploy your stuff, you say, oh yeah, 2 CPUs and 32 gigabytes of RAM. Oh yeah, that's really nothing. Today in a public cloud, everybody's using that all the time. So if you run that for a year, your workload, it's the same as one transatlantic flight over the ocean, roughly, in terms of carbon emissions. Very rough, but to give you an idea about, if I would talk to you about from the sustainability aspect, should you avoid taking a transatlantic flight? Everybody would say, oh yeah, of course you should try to avoid that. Flying transatlantic all the time, that's not a good idea. I say, you should maybe try to avoid 2 CPUs and 32 gigabytes of memory. It's the same, round about the same. And it's just one flight. It's not forth and back, right? Just one flight. With that in mind, don't forget the scaling effects. Don't forget about your software probably running maybe not one instance, but you run that with a backup instance. You run that with a test instance. You have a staging area with the same environment. Maybe you scale your stuff up in production to a high number depending on your load. So if you have a lot of load, you're scaling that up to high numbers. Not everybody is running stuff at the Netflix or Google scale, but probably a lot of stuff is being scaled. Using many, many instances, those numbers scale up as well. If you can save stuff, that is important. And don't think too much about those small numbers. Because those small numbers, they look very small, but if you take the energy production into account and the data center and the cooling and whatever, it actually makes a lot of sense to reduce the small things. And this is, for example, one thing that a team inside of our Spring org is also looking at. Is trying to shave off those numbers, right? Trying to shave off those hardware requirements of your workloads. And that is also an interesting effect when we can use these kind of scaling effects, right? So we do Spring and Spring Boot. There are millions of workloads in the world running on Spring and Spring Boot. Millions. All the time in all the data centers around the globe, right? Millions of workloads. There are even millions of developers using that. We try to combine Spring with GraalVM technology using Spring Native, allowing you to compile Spring applications up front to a native executable. Right? That's at least kind of an interesting technology combination, and it helps you to kind of make your stuff smaller. And the interesting outcome of this is, of course, the main driver for this is make it start up super fast, allow Spring apps to be used in serverless environments, use less resources on the cloud because then it gets cheaper. But if you can achieve something with this approach, saying, okay, we have the framework team, this allows you to do something like this, and this kind of takes your memory consumption down to half, takes your CPU consumption down to half, or maybe down to a fourth. So you can do the same as before, but with half of the memory. Think about scaling that up. Think about, what if 1 million workloads running on the globe would all use half of the memory? Giant amount of energy could be saved. So if you work on something that is used by others, right? You work on a library, you work on an open source project, you work on a platform inside of your organization. Think about those effects. So you have a multiplier effect within those things. Really, really cool. One thing that is missing, I think, at the moment, and something that will be there by, I don't know, within the next years, I think. And this is what we heard this morning that the Green Software Foundation is working on, kind of feedback loops, giving you information about your carbon consumption, your carbon emissions, the energy consumption of your software, so that you can actually get these feedback loops and see what is the effect of the stuff that I'm doing. I think that is super important to allow you to really keep that number in mind, this carbon, the software carbon intensity factor. Keep this in mind and see how does that evolve over time. Is it going up? Is it going down? Who knows, right? You can go home from this talk and say, oh yeah, Martin talked about a lot of interesting stuff. I should use less. And then in the end, do you really know how much you saved? Do you really know the exact carbon intensity numbers? It's hard. And it is still hard, and I don't have a solution for that. But this carbon intensity factors and in closing up the feedback loops will come, and it will be an interesting thing. So if you're interested in kind of innovating in this area, definitely a space to innovate. Put this out in open standards, like the carbon intensity stuff from the Green Software Foundation, and going to the website where you can find more links to, for example, these carbon-aware SDKs, a project where people join forces to think about these SDKs to measure your carbon impact of the software that you're producing and that you are running. So remember, you can have a huge impact. Right? It's not just the small thing. It's not just, it's nothing, I don't need, I just wait, I can relax. You can have an impact. You can have a huge impact when you write your software. Keep that in mind and go home with that thought about, I can have this impact and I should do it. So do it. It's really important. And with that, thanks for listening. And I, of course, totally forgot to mention that you can ask questions anytime, which is great to mention in the end. Sorry for that, but of course you can ask questions anytime. So there's a question. I'm super happy to answer questions if I can, right? In the past, it was kind of 80% of the questions, I have no idea.
Assuming a hypothetical application that scales perfectly and is perfectly load balanced, do you have any data on whether it's more efficient to run it on a smaller amount of larger instances versus a larger amount of smaller instances?
Oh, that's in the category, I have no idea. No, I don't know. I don't know whether it's more efficient to run that on a big instance, big node, basically. Many stuff on a big node, where there's many things on small nodes. I don't know. Sorry. More questions? If not, then thanks a lot for coming. Thanks a lot for listening. Thanks a lot for joining this session. I hope you liked it and hope you can take something away from it and enjoy the rest of the conference. Thanks a lot.